steps to solve a linear equation. Here are the 6 steps. I just did a Google search and I pulled up 6 steps, but I am going to add a first step, right? So it says 1, clear the parentheses. 2 says combine any like terms. The third step is to isolate the variable term on one side of your equation. The fourth step, which is kind of simultaneous with the third step, you want to isolate your constant term on the opposite side. Then you want to divide by your coefficient so that you can solve for your variable alone. And then the last step is to check. The first step that I'm going to add to this, I'm actually going to call this step 0, and it would be to remove fractions. So if you're encountering a linear equation that contains a fraction, the first thing you want to do is remove that fraction, and you remove it by multiplying both sides of the equation by the least common denominator or the least common multiple. And we're going to see an example of that. Okay, so that should be your first step if you have a fraction. Then this next step should be to clear the parentheses by using that distributive property. Okay, and then we follow the rest of those steps to solve a linear equation. Now, what exactly is a linear equation? Well, on this graphic organizer, we take a look at the linear equations in 3 forms. First, there's what's called the standard form. And the standard form of a linear equation is a linear equation in which both your variables are on one side of your equation together, and your constant is on the opposite side. We have another form called slope-intercept form, which is y is equal to mx plus b. And then if we're trying to write out equations, we have what's called the point-slope form. Okay, and we don't use this point-slope form in this particular course. Okay, the only 2 forms we're going to look at are the standard form and that slope-intercept form. Now, what makes a linear equation is the fact that no variables should be raised to anything other than the first power. So if you take a look at the slope-intercept form, y is equal to mx plus b, notice that the variable y is raised to the first power. The variable x is raised to the first power. So this would give us a linear equation. If we had powers higher than the first power, then we run into other polynomials such as quadratic, cubic, quartic, that sort of thing. All right. But in this particular module, we're taking a look at linear equations. So let's take a look at solving a linear equation by using those steps. All right. So here's the first one. It just says solve the given equation. So if we keep those 6 steps in mind, I'm just going to follow those 6 steps as we go through the problem. That first step would be to remove any fraction, which we don't have. The next step, we're going to remove parentheses. And we remove parentheses by using the distributive property. So if we take a look at our problem, notice on the left-hand side, we have a set of parentheses. So I'm going to distribute 3 . Okay, so I'm going to distribute 3 within that first set of parentheses. So 3 times a is 3a. minus 3 times 4 is 12. I'm going to bring everything else down. Minus 6 is equal to 9. All right, so once you use the distributive property, that should remove any parentheses. Let's see if this is a little bit better. All right, so the next thing I want to do is I want to combine like terms on both sides of my equation. So this equal sign, it separates this equation up into a left-hand side and a right-hand side. All right, so if I look on my left-hand side, I have two like terms, which are these constants. So remember, a constant is just a single number. There's no variable attached. So I'm going to bring down 3a. Negative 12 minus 6, that's going to give us minus 18. And I'm going to bring down the equal to 9. The next thing I'm going to do on our 6 steps, after we combine like terms on both sides, the next thing we want to do is isolate the variable. So that means that I want my variable term, so notice my variable term is 3a, right, because it has that variable a attached. And then negative 18 and this 9 are constants. I want to keep all my variables on one side, and I want to move all my constants to the other side. Since there's only one variable term, I'm going to let it stay on the left-hand side. I'm going to transpose, or I'm going to move negative 18 across my equal sign. So that'll put all of our constants on the right. Whenever you move terms across the equal sign, you must change their signs. So when I move negative 18 from the left-hand side to the right-hand side, it's going to change sign, right? So that's what transpose means. When you move entire terms across your equal sign, you must change the sign. All right. So now we have 3a is equal to 18 plus 9. The next thing I'm going to do is simplify my right-hand side. I'm going to bring down 3a. 18 plus 9 is 27. The next thing I'm going to do is I want to isolate for my variable, which means that we want to solve this equation for a, not for 3a. So the opposite of multiplying a by 3 is to divide by 3. So whatever you do to one side, you must do the same thing to the other. So I'm going to divide both sides by 3. On the left-hand side, the 3's cancel, so I'm left with a. And 27 divided by 3 is 9. All right, so for this example, a is going to equal to 9. All right. All right, if we take a look at the next problem, right here again, we're asked to solve. This one contains a fraction. So the first thing we want to do is to remove the fraction. So that was like our step 0. So in order to remove the fraction, we have to multiply both sides of our equation by the least common denominator or the least common multiple. So here, since my denominators are only constants, I'm going to find the least common multiple. So what is the least common multiple? Well, first I have to find the multiples of 3. So the multiples of 3 are just like counting by 3. So The multiple of 3 are 3, 6, 9, 12, 15. That's going to keep on going. The multiples of 2 are 2, 4, 6, 8, 10, 12. That keeps on going. We want the least common multiple. So if I look all of my multiples, the smallest multiple that's common to both would be 6. So that's my least common multiple, 6. So I want to multiply the left-hand side and the right-hand side by 6. All right. So we have everything multiplied by 6. Now we're going to physically multiply it. So we're going to distribute 6 in this first set of parentheses. Notice that when you multiply 6 times this first term, x minus 2 over 3, the 6 and the 3, that reduces to a 2. So now I actually want to distribute 2. So 2 times x is 2x. 2 times negative 2 is negative 4. I also must multiply 6 by my second term on the left-hand side, which is x over 2. So keep in mind that we're multiplying both sides by 6, right? So it was reduced down for the first term, but when we distribute, we're distributing 6. So I'm reverting that back to a 6. 6 and 3, or excuse me, 6 and 2, that's going to reduce down to 3. And if I distribute my 3, I have plus 3x. And if we multiply 6 by the right-hand side, that right-hand side is equal to 6. All right, so we have removed the fraction, okay, by finding that least common multiple. That was our first step. The second step, we're going to combine like terms on both sides. So if we look on our left-hand side, notice that we have a 2x and a 3x. So I'm going to combine those. 2x plus 3x is 5x. I'm going to bring down minus 4. And I'm going to bring down 6. All right. And on the right-hand side, there's only one term, so it's simplified. Our next step is to isolate the variable term. So notice that there's only one variable term, and it's on the left-hand side. So I want to take negative 4, and I want to transpose it or move it to the opposite side. So upon doing that, I'm going to change its sign. So it becomes positive 4 on the right-hand side. I'm going to combine like terms again on my right-hand side. Six plus 4 is 10. The last thing I want to do is solve for x. So the opposite of multiplying x by 5 is to divide by 5. So if we divide both sides by 5, x is going to equal to 2. Get some handouts back. All right, so for that problem, we had a fraction. So your first line of action should be to just get rid of the fraction. All right, now the next question, it involves those 6 steps, but this is what's called a literal type equation, which means that we can't actually solve it because there's too many unknowns, but we can rewrite the equation. So in this example, we're given 4x plus y is equal to 3, and we want to solve it for y. So in essence, we want to isolate for our variable term y. Right? So the first thing I'm going to do is I'm going to locate the variable or the term in which I'm trying to solve for, which is y. I'm going to look at every term that's on the same side as y. So there's only one other term, which is this 4x. So I'm going to take this 4x and I'm going to transpose it to the other side. So when I transpose entire terms about an equal sign, when you move from one side to the other, you simply change your sign. So I'm going to let y remain on the left-hand side. I'm going to bring down 3. And then I'm going to transpose 4x. So I'm just going to make it negative and move it to the right-hand side. And this should be our solution. We have solved or isolated for y. So in this case, we simply subtracted 4x from both sides. Okay, now in the second module, you will also have to set up some equations. So this is number 16, and this is from 3.1. All right. So it says a profit in dollars from selling X units of Blu-ray players is given by this expression, 50x minus 250. We're asked to set up and solve an equation to find how many Blu-ray players must be sold to obtain a profit of $750. So they give us the equation for selling Blu-ray players, which is 50x minus 250. We want to know how many Blu-ray players must be sold. So in this particular expression, X is the number of Blu-ray players that must be sold to obtain a profit of 750. So I'm going to take this equation, which is our profit equation, 50x minus 250, and I'm going to set that equal to $750. So we want to solve for x. Right? So we don't have any fractions. We don't have any like terms on both sides. So I'm going to isolate from my variable term, which is 50x. So in order to isolate for 50x, I'm simply going to take this negative 250 and I'm going to transpose it or move it to the other side. So now on my left-hand side, I now only have 50x. I'm going to bring down 750. And when I move this negative 250 to my right-hand side, it becomes positive 250. So when you move entire terms across an equal sign, you simply change your sign. So now we have 50x is equal to 750 plus 250. So let me write some steps. So the first thing I did was transpose negative 250 to the right hand side. So that's simply when I move it across the equal sign, it just simply makes it positive. I brought down my 50x. I brought down my equal sign. I brought down my 750. So now I'm going to combine like terms. So on my left-hand side, there's only one term. So I'm going to bring that down. On my right-hand side, I can add 750 plus 250, which should give us 1,000. All right, so what I just did here was simplify. So the next thing we want to do is we want to solve for x. So the opposite of multiplying x by 50 is to divide by 50. So I'm going to divide both sides by 50. Right? Because whatever you do to one side, you must do the same thing to the other side. So on the left-hand side, my 50s are going to cancel. I'm left with x. And if you divide 100 by 50, we can like cancel out those last zeros, and 100 divided by 5 should be 20. So if you sell 20 Blu-ray players, your profit would be $750. Right, then I think there's one more for the linear equation section. All right, so it's another word problem, and it states that the total amount of spending for law enforcement by the federal, state, and local governments in the year 2005 was $313 billion. Since then, it has increased by 9.42 billion annually, which means per year. In what year did the total amount spent on law enforcement equal 397.78 billion? All right, so we're going to set this up in the form of an equation. So first we have, when you set up equation, you have a fixed amount and a fixed amount is something that's not going to change. Plus or minus, because it all depends upon what you're dealing with. A variable amount so the word variable means that it can change. It's an unknown quantity. And we're going to set that equal to the total amount. All right. And I'm going to set this up in the form of an equation. So from our problem, the fixed amount is going to be 313 billion, and that was in 2005, right? The government spent a total of 313 billion. So that's our fixed amount. And since then, it has increased. So since we have an increase, that is plus 9.42 $9.42 billion annually. So that's what's variable. So it's 9.42x, because x is going to represent the number of years since 2005. So we have 313 plus 9.42x, and we're going to set that equal to the total amount that was spent on law enforcement, which was 397.78 billion. Right? So that kind of fits this equation. And this is like called a cost equation. Sometimes it can be a profit equation. It's all based on the situation. But you should have a fixed amount. That's something that can't change. That's that 313 plus a variable amount. So the variable amount here is the 9.42 billion annually. So we don't know quite how many years it would take to get this total of 397.78 billion. So now that we have it laid out, we're going to solve it for x. So I don't have any fractions. I don't have any parentheses. I don't have any like terms on both sides. So my first step here would be to transpose that 313 billion to the right-hand side. All right, so I'm just simply going to move it across the equal sign and change its sign. So I'm going to bring down 9.42x. That's equal to, I'm going to bring down 397.78. And then on that right-hand side, it's going to be minus 313. Because we transpose that positive 313 across the equal sign, and that changes its sign. All right, so now we're going to combine like terms. There are no like terms on the left-hand side, so I'm going to bring down 9.42x. On the right-hand side, we're going to subtract. So let me bring up the calculator. $397.78 minus 313. We get 84.78. Now the last thing to do here is to solve for x. So the opposite of multiplying x by 9.42 is to divide both sides by 9.42. And on the left-hand side, the 9.42 will cancel, which leaves x. And if we divide the right-hand side by 9.42, we get 9. But this doesn't quite answer the question, though. It wants to know in what year. So we started at 2005. We got x equal to 9, but keep in mind that 9 represents the amount of years. So if we were to add the 9 plus the 2005, we would get the year 2014. So in the year 2014, the total amount spent on law enforcement was the 397.78 billion. Any questions about number 17? All right, so that was the first section in module 3.1, which was the linear equation module section. Okay, so that should have been somewhat familiar. The word problems at the end, not so much. All right, now in the next section, so this is the 3.2 set of notes or homework section. We talk about a quadratic equation. Here is the definition of a quadratic equation. It's just a function that's set equal to 0 from which the roots, and when you see this word roots, that's the same thing as solutions, and that's the same thing as the answers of the quadratic equation can be found. The solutions and the answers and the roots, those are the items that are plotted on this x-axis. So we'll see how that works in a second. Here is the standard form of a quadratic equation. You have ax squared plus bx plus c equal to 0. Notice that a, b, and c are real numbers. So even though they're letters, they're not really variable. They're actually numbers. The only variable is x. All right, one of the x's is squared, and one of the x's is to the first power. Another thing, notice that for quadratic equations, they're going to have exponents raised to the highest power of 2. So notice if I go back to the linear equations, we didn't have any exponents larger than 1. So that's what makes a linear equation linear. For a quadratic equation, the largest exponent is 2, right? You can have exponents to the first power, but the largest one can't exceed the number 2, right? So anytime you see equations with variables squared, those are quadratic equations. The way you solve a quadratic equation and the way you solve a linear equation are totally different. So I've just added a slide. It's just something I pulled up online. It's just methods for solving quadratic equations. And there's actually 4 methods to solve a quadratic equation. And I'm just going to jot these over here. These are methods to solve a quadratic equation. The first method is factor and zero factor property. Right, so that's one method, is to factor it and use a zero factor property. The second method is the square root property. And the square root property says if a squared is equal to c, then a is equal to plus or minus the square root of c. We're going to take a look at these. There is a third method, and it's called complete the square I'm just gonna put a star by this one. This is like the most complicated out of all of the ways to solve a quadratic equation. And then the fourth method is the quadratic formula. And it is the most powerful method. So what I mean by the most powerful method is, in order to use those first three methods to solve a quadratic equation, the quadratic equation must be in a certain form. But when using the quadratic equation, the only thing you have to do is put it in standard form and use a quadratic equation. It will work every time. But the factoring zero factor property method, that can't be used all the time because all of the quadratic equations aren't factorable. That doesn't mean they don't have an answer. That just means you can't answer them. In order to use the square root property, you must have your squared term and your constant term only. And then in order to complete the square, you have to have a certain form, which is the squared term and the first degree term. But the most powerful is this quadratic formula. So irregardless to what the question, which method the question tells you to use, you can always use this quadratic formula. All right. So this little screenshot is provided gives you some indications on how to use those methods. The first one says if x squared equals a number. So notice I have a second degree term. So when you hear me say second degree term, that's just the term that has a second power, second root on it. If I say a first degree term, that's just the variable raised to the first power. So if you have your squared term and your constant term, you can use that square root property. The second one says if you have an x squared term and an x to the first, you use the complete the square, or you can factor. The third says you can use the factor method. The fourth one says you can use, this is a factor by grouping method, which we don't quite use. Fifth is the quadratic formula, and then 6 is also the quadratic formula. All right, so just some things to look out for. And I just included that. It was a snapshot on the Google search. Right, but here are the steps to solve a quadratic equation by factoring. All right, so we're going to look at each one of these step by step. First thing it says is get the equation into standard form. What is standard form? Standard form means that the quadratic must be set equal to 0 and the is positive. So for the quadratic formula and for this method of solving, the equations must be in standard form. That means it's set equal to 0 and that squared term must be positive. If it fits that first condition, the next thing you're going to do is factor. So remember that factor and the FOIL method are reverse processes. So we'll review that some. The next step is you use the zero factor property. So the zero factor property says if A times B equal to 0, I can take each factor and set each factor equal to 0. So if A times B equals to 0, then I can set A equal to 0 and B equal to 0. And then the last step says solve. All right, so let's take a look at an example. All right, so here is the example. It says solve the quadratic equation by factoring. Right, so here they're telling us to solve it by factoring, but you don't actually have to solve it by factoring. You can use a quadratic formula. Right, but this is the factor method. The first thing you gotta do is make sure it's in standard form. Standard form means that it's set equal to 0 and it's set equal to 0. And the squared term must be positive. But our squared term is negative. But we can force the squared term to be positive. So what I'm going to do here is multiply both sides by a negative. I don't know why this keyboard is not. So I'm going to multiply the left-hand side by a negative. And I'm going to multiply the right-hand side by a negative. All right, so just remember there's something called properties of equalities that state whatever you do to one side of the equation, you have to do the exact same thing to the other side of the equation to maintain equality. So I multiply both sides by a negative. So now I'm going to distribute. So a negative times negative 3x squared, that's positive 3x squared, which is what we want. A negative times a positive 5x is negative 5x. A negative times a positive 2 is negative 2. And 0 is neither negative nor positive. So now we have our equation in the correct form. All right, so now we have to factor. So factoring and the forward method are reverse processes. So if you remember back to the forward method, first, outer, inner, last. And it was just the way that you multiply. So we're going to reverse that process and we're going to factor. So we're doing a reverse forward method. So the first thing I'm going to do is make two sets of parentheses and I'm going to set equal to 0. Because the word factor simply means to write as a product. And product means something times something else. So we're taking this trinomial 3x squared minus 5x minus 2 and we're factoring it. We're going to write it as something times something else. Now, if you think back to the forward method, whatever you put, let me give myself a little bit more space. Whatever you put as your first terms, when you multiply them, it's got to give you the first term in your trinomial. So now the only way I can get a 3 is by 3 times a 1. And then for x, I'm going to have x times x. That gives you x squared. So for 3x squared, I'm going to break this up into 3x and x. Because when you multiply 3x times x, you get 3x squared. Whatever numbers I put as my last terms, I should be able to multiply and get the last term in my trinomial. All right, so whatever I put here and here, I should be able to multiply them and get a -2. The only way I can get a 2 is by a 1 and a 2, right? And the only way I can get a -2 is that one of those numbers has to be positive and one of those numbers has to be negative. So I'm going to put -1 and I'm going to put +2. So the first term's 3x times x is 3x squared. For my last terms, -1 times a +2 is a -2. You have to check this middle term. So what do you have to do to check the middle term? Well, in this FOIL method, when you multiply the first terms, that gives you the first term in your trinomial. When you multiply the last term, that gives you the last term in your trinomial. But when you multiply the outermost and the innermost, so let's see what happens. If I multiply my outermost, 3x times 2 is 6x. If I multiply my innermost, -1 times x is -x. So now if I add these together, -x plus 6x gives me 5x. In order for this to be the correct factorization, these must also be equal. And they're not, right? I mean, this is a positive 5x and this is a negative 5x. So this is not the right factorization. I just want you to see this because sometimes you have to do a trial and error. So what I'm going to do now is I'm going to switch up my numbers. Right, so now this is not the right factorization because the first term checks out, right? The last term checks out. But when I multiply my outermost and my innermost terms and add them up, these are not the same. So I'm going to try it this way. 3x squared minus 5x minus 2 is equal to 0. I want to make two sets of parentheses. I'm still going to use 3x and x. But this time, I'm going to use a +1 and a -2. So I want you to see how this works. So if I multiply my first terms, 3x times x, that still gives me 3x squared. If I multiply my last terms, 1 times -2, that still gives us -2. Now I'm going to check the middle term. So in order to check the middle term, I'm going to multiply the outermost terms. So 3 times -2, that's -6x. I'm going to multiply my innermost terms. 1 times x is x. X minus 6x is -5x. And this is the correct factorization. All right, so you get the first, getting the first and the last are easy. But getting the middle term, sometimes you may have to use a little bit of trial and error. All right, so we've taken 3x, I'm just going to write it over here. 3x 3x squared minus 5x minus 2 equal to 0. We factor that down to give us 3x plus 1 times x minus 2 equal to 0. So we factored it. If you were to multiply these together, you should get this. Next, we're going to use that zero factor property. So here we factor. The zero factor property says if a times b equal to 0, then a equal to 0 and b equal to 0. So if we think about for our first factor, this is a times that second factor is b, and it's equal to 0, like our formula. I can set a equal to 0, so that means I can set 3x plus 1 equal to 0. And I can set b, which is x minus 2. I can set that equal to 0. And now I can solve for x. So notice that these equations now are linear because I don't have that second power anymore. So in order to solve these, we're going to use those 6 steps to solve a linear equation. So in order to solve 3x plus 1 equal to 0, the first thing I'm going to do is transpose 1 to the other side. So when I move positive 1 across the equal sign, it becomes negative 1. Next, I want to isolate for x, not 3x. So the opposite of multiplying x by 3 is to divide by 3. Right? So we have one of the solutions as x is equal to negative 1/3. And if we solve this equation for x, I'm simply going to transpose negative 2. So when I move it to the other side, it becomes positive 2. So my two solutions are negative 1/3 and positive 2. All right, now in the interest of time and of some headaches going through this stuff, we're only going to look at two methods: the factor and solve and the quadratic formula method. So I'm going to take this same problem that we just factored, and we're going to use the quadratic formula, and we should get the same exact answers. So I'm going to just scroll down a little bit, and here is the quadratic formula. And it's like the most powerful method because you can solve any quadratic with it. All right, so it says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I'm gonna rewrite that formula. But let's go back to this problem. Right, negative 3x squared plus 5x plus 2 is equal to 0. And we're going to use the quadratic formula. here it is. Negative 3x squared plus 5x plus 2 equal to 0. So the only thing you really have to do in using a quadratic form is you have to make sure it's set equal to 0. You could change everything to, well, let me just be correct. Let me put it in standard form. So it's set equal to 0, and then our first term has to be positive. So I would start out the same way. I would multiply both sides by negative. So we get 3x squared minus 5x minus 2 equal to 0. So that first step is the same. Put in standard form. And now I want to use a quadratic formula. So for the quadratic formula, a, that's going to equal to the coefficient of the first term. So just remember, coefficient means the numerical part of a term. B is the coefficient of my middle term. You want to make sure you keep the number as well as its sign. C is going to equal to the constant. So now that we have A, B, and C, you're just going to plug everything into this formula, which is a lot easier than factoring. Factoring can be involved depending on the equation that you have and what's all involved in factoring. Sometimes it can't be factoring. Sometimes you may take you a while to figure that out. But for the quadratic form, it's just straightforward. All right, so we put it in standard form. We pulled out A, B, and C. So x is going to equal to negative, because that's a part of the formula, times b, which is a negative 5. You have to make sure you keep all operations and signs, plus or minus the square root of b squared. So b is negative 5 squared minus 4 times a times c, right? Because negative 4 is a part of our formula. A is positive 3. C is negative 2. All over 2 times A. So I just substituted A, B, and C into the formula. And now we're going to simplify. All right. So a negative times a negative, that makes a positive. So that's positive 5. This plus or minus is important because it breaks us out into two answers. Now, as far as the square root is concerned, remember the order operations. Please excuse my dear Aunt Sally. So the first thing I want to do is whatever's in the innermost parentheses. Well, if I look within this square root, I don't have an innermost parentheses. This set of parentheses is telling me that negative 5 is the base, 2 is the exponent. These sets of parentheses are telling us to multiply. So there is no innermost parentheses. Next thing you would do is please excuse or evaluate any exponents. So negative 5 times negative 5, that gives us a positive 25. So it's please excuse. So excuse is for exponents. My dear. So you want to do multiplication and division, whatever comes first from left to right. So now I simply want to multiply these numbers. So negative 4 times 3 is negative 12. Negative 12 times 2 is positive 24. Right? Divided by 6. Right, so the first thing we did on the inside of this square root is we evaluated our exponent and then we multiplied. So on the next step, we're going to simplify the inside of the parentheses. So 25 plus 24 is 49 divided by 6. Right. So I have 5. I want to bring down a plus or minus. The square root of 49 is 7 divided by 6. Right. So now here's where the two answers come in. X is going to equal to 5 plus 7 over 6, or 5 minus 7 over 6. So this plus or minus separates out our two answers. So for this first one, 7 plus 5 is 12. 12 divided by 6 is 2. For that second one, 5 minus 7 is negative 2. And negative 2 over 6 is negative 1/3. We found the exact same values without factoring. So for our purposes, even though I have this other stuff on the slide about the square root property and complete the square, I would only want you to use really the square root, the quadratic formula. I just want to show how that works. You can do it both ways. The next problem, okay, like this one, it says solve the quadratic equation by completing the square. So like I said, out of all of these methods, completing the square is like the most involved. I'm going to use the quadratic formula. Right, so it really doesn't matter what method you use. I could also try to factor. All right, but the most straightforward method is this quadratic formula. Right. Quadratic formula. So I have to put it in standard form. T squared minus 6t is equal to negative 5. So in order to put this in standard form, I have to make it equal 0. So in order to make it equal 0, I'm going to take negative 5 and transpose it to the other side. So this gives us t squared minus 6t plus 5 is equal to 0. I believe you can factor this one. So I'll do it both ways. So in order to factor, I'm going to make two sets of parentheses, set it equal to 0. I can put t in the front, right, because t times t is t squared. In order to get positive 5, I'm going to put a negative 1 and a negative 5. I could also put a positive 1 and a positive 5. But the reason why I'm using a negative 1 and a negative 5 is because of the middle term. So if I take my outermost terms, t times negative 5 is negative 5t. I can take my innermost terms, negative 1 times t is negative t. And if I combine those, that will give me that correct middle term. So now that we have the correct factorization, I can take each factor, set it equal to 0. So that's t minus 1 equal to 0. And I can set t minus 5 equal to 0. And if I solve, I get t is equal to positive 1 and positive 5. Here is the quadratic formula method. So this is the factor method. And here is the quadratic formula. So if we were using that quadratic formula, we would still have to put it in standard form, make it equal to 0, and the coefficient of the first term is 1. So A is going to equal to 1, B is going to equal to negative 6, C is going to equal to positive 5. And if we rewrite the quadratic formula, I mean, it might be a little bit time consuming, like working all out in this quadratic formula, but it's the most straightforward method. So once we substitute our values in, a negative times a negative 6 is positive 6, plus or minus negative 6 squared minus 4 times A times C all over 2A. So I just substituted A for 1, B for negative 6, and C for 5. So now we're going to simplify the square root. So I'm going to just bring over 6. So just remember, in that square root, we evaluate our exponent first. So negative 6 squared is 36. Now we're going to multiply. So negative 4 times 1 is negative 4. Negative 4 times 5 is negative 20. And that is all over 2. All right, so now that we've evaluated our exponent and we've multiplied inside of our square root, the next thing to do is to subtract. So x equal to 6 plus or minus the square root of 16 over 2. And I'm going to simplify the square root of 16. Simplify that to 4. We're going to use a plus or minus to separate out our two answers. So x equal to 6 plus 4 over 2 and 6 minus 4 over 2. So that's 10 over 2 and 2 over 2. So we get the same 5 and 1. All right, so irregardless of what the question asks you to do, I would only use the factor method and the quadratic formula. All right, now the last thing is, okay, what is number 13? Okay, now this one actually says to use the quadratic formula. Now, when it actually asks you to use a quadratic formula, that kind of implies that you can't factor. So like for this trinomial, z squared plus 6z minus 3, we cannot factor it using the factor zero factor method. But we can use the quadratic formula. So since it's already in standard form, a is going to equal to 1, b is equal to 6, c is equal to negative 3. I'm going to rewrite the quadratic formula. And now we're going to substitute it. So x is equal to negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 3 over 2 times 1. So now we're going to evaluate the exponent within the radical. 6 squared is 36. Now we're going to multiply. Negative 4 times 1 times 3 is positive 12 over 2. So x is equal to negative 6 plus or minus the square root of 48 over 2. Now here's where you may have to, well, not may have to, you will have to simplify radicals. So in order to simplify a radical like the square root of 48, to simplify radicals, we use something called a product rule for radicals. And it says that the nth root of a times the nth root of b is equal to the nth root of a times b. So like if I had the square root of 48, what two numbers could I multiply to get 48? Well, I could have like the square root of 1 times the square root of 48, right? That'll give me 48. But I only want to choose, or at least one of the numbers I choose, I want it to be a perfect square. So like if I look at 16, right, and my perfect squares are 4, 9, 16, 25. So like the square root of 4, these are called perfect squares. So like the square root of 4 is perfectly 2, the square root of 9 is 3, square root of 4 is 5, square root of 25 is 5, right? That'll like keep on going. What's the largest perfect square I can use as a factor of 48? Well, I think I can use 4 times 12, right? Because 4 is a perfect square. But is that the largest one? Well, I believe I can use 3 times 16 or 16 times 3. Right, because 16 times 3 is 48, right? Let me just verify that. Yeah, 16 times 3 is 48. So 16 is the largest perfect square. All right, so that means I can rewrite the square root of 16 as 4. The square root of 3 has to remain, well, 3 has to remain inside of that square root. So now these two numbers, 4 times the square root of 3 and the square root of 48, they are the same numerical value. Right? The square root of 48 is 6.928. 4 times the square root of 3 should be the exact same number. The only difference is 4 times the square root of 3 is in simplest form, whereas the square root of 48 is not. So you must always put radicals in simplest form. So now if we go back to our problem, I'm going to rewrite 48 as 4 times the square root of 3 over 2. So now I'm going to work this a little bit differently toward the end. So I'm going to separate this out. I'm going to separate this out as negative 6 over 2 plus or minus 4 square root of 3 over 2. Now I'm going to reduce. So negative 3 divided by 2, negative 6 divided by 2 is negative 3. The 4 and the 2 are going to reduce down to 2. And then these are my answers. X is going to equal to, that's fine. S is going to equal to negative 3 plus 2 square root of 3 and negative 3 minus 2 times the square root of 3. So those are the two solutions. So now in this section, regardless of what the problem says, I would only really prefer to use the factor method and a quadratic formula. Any questions about that? All right, now the last thing is something called the discriminant. And if you look at the quadratic formula, the discriminant is the expression underneath the radical, the b squared minus 4ac. So the discriminant says if you were to evaluate b squared minus 4ac, which means if you were to substitute a, b, and c, if that value is greater than 0, the quadratic has 2 real roots. If the discriminant equals to 0, there is only 1 real root. And if the discriminant is less than 0, there are no real roots. So now here are like the roots. Remember that the roots are the solutions, and the roots are also where the graph crosses the axis where is the picture here? So like here, 2 real roots means that your graph actually hits the x-axis twice. If the discriminant is 0, that means that your graph hits the x-axis once. And if the discriminant is negative, your graph does not touch the x-axis at all. All right, so the last problem, it gives us a quadratic x squared minus 2x minus 3, and it wants us to find the value for the discriminant and the number of solutions. So I'm going to put in, okay, A equals to 1, B equals to -2, C equals to -3. So remember, it would still have to be in standard form. So we're going to put in B squared, so that's -2 squared minus 4 times 1 times -3. So first thing I'm going to do is evaluate my exponent. -2 squared is a +4. And then I'm going to multiply. -4 times 1 is -4. -4 times a -3 is a +12. 4 plus 12 is 16. So that means that the discriminant value is 16. And then it asks for the number of real solutions. Okay, well, if we look back at our discriminant chart, since 16 is greater than 0, that means that that quadratic has 2 real roots. So the discriminant is 16 and the number of real roots is 2.